Hello! We're going to talk about graphical transformations, and we did most of this in the lab today. And so the first two are what we looked at in the lab. We looked at translations and reflections. And these graphical transformations, as we said, are the ways that the graph changes. And so the third one is compressions and stretches, which we're going to get to in this video. So we talked about two types of translations, the horizontal, oh my gosh, and the vertical. And so hopefully you saw from your activities today that the horizontal, and this is, we're basing on y equals f of x, right? That's our original function. So the horizontal translations is when they moved left or right, and these had f of x minus c, or f of x plus c. Okay, and so the difference here is this minus c and this plus c. So what did this minus c do and what did this plus c do? Well, this horizontal is left and right, so the minus c, hopefully you noticed, moved the graph right c units, and this plus c moved it left. Okay, and then this vertical, right, vertical goes up and down, and so again, this time y equals f of x plus c, and this c is on the outside, and then y equals f of x minus c, and this c is on the outside. And so this time, this plus c moved the graph up c units, and this minus c moved it down c units. Okay? And so when you think plus, you would think up, and when you think minus, you would think down. This, though, doesn't work like that, right? On the graph, if you think minus c, you think it's going to move left, but actually it moves right. If you think plus, you think it's going to move right, but it actually moves left. And that's because of what happens when you make these equal to 0. This will equal positive c, this will equal negative c, and so that's what ends up happening. And then the back of the activity that we did in the computer lab today, you saw some reflections, and you should have noticed that most of the graphs that you were drawing looked like this, and then flipped over or reflected over this x-axis line. And the reason that happens is because of the negative. And so the reflection rule is y equals, negative f of x, right? When I see that, this negative, that's what flips it, reflection over the x-axis. Okay, and so we're going to look at an example with those, and then we'll get onto compressions and stretches. So, looking at these two, sketch the graph or identify the equation. So here we're given the equation, sketch the graph. Here we have the graph, so write out the equation. Well, I see that both of these are based off the graph that we've been looking at, which is f of x equals x squared, and we know that that shape's going to be a parabola. And so this one, the difference here is this plus 3 and this plus 2, right? That's what's changed. And so how is that going to change the graph? Well, this one's inside with the function, and this one's outside. So if we look back at these rules, okay, the ones inside caused a horizontal, the ones outside caused a vertical change. And so the horizontal, both of those values we had were plus, right? So the horizontal inside plus c is going to move it left, and outside this plus c is going to move it up. So we know that this graph's going to go, this plus 3 is going to move it left 3 units, and this plus 2 is going to move it right 2 units. And we also should notice that this is in vertex form. Well, wouldn't this give us our vertex? right? Wouldn't our vertex be negative 3, 2? And so isn't that what happens here? This graph goes left 3 and up 2, right? Making our vertex at negative 3, 2. And so the vertex form is essentially the translations. So does this graph face up or down? Well, we talked about that here. The reflections, if there's a negative, then it reflects down. Also, that's based on the A value, which we talked about the other day. But there's no negative here, so this graph's going to face up. And that would be the graph. Okay? In this second one, I'm given the graph. I want to write the equation. Okay? So again, I know it's based off of this f of x equals x squared. So I have f of x equals, and now I got to figure out how is this graph moved. Okay, well here's 0, 0, so we need to find out this vertex, right? And you'll note that this graph goes up by 2's, okay? So here I go over 2, well it's not quite to 4, it's in the middle, so this is at the 3 line, right? And then how many does it go down? Negative 2, negative 4, right? Because these go down by 2. And so my vertex here is at positive 3, negative 4, which means the graph moved right 3 and down 4. Okay, so when we're graphing this, we also notice that my shape is downwards, right? So I'm going to have a negative on the outside here. Now I have my x, and I'm going to fill this with a squared, but I know that there's a horizontal translation, so something else is going to go in this parentheses. And so this moves right 3. Okay, so let's look at that again. Right has a negative c, right? Minus c, so that's going to be minus 3. And then down 4 means I'm going to subtract 4, because the negative 4 moves it down 4. And that would be my equation. Okay? All right. Stretches and shrinks are caused by the a value, which is multiplied by the x squared function. So a reminder down here that the vertex form is here. So based on my a value, we've seen some equations before where this a wasn't just a 1, it was a number. And so that number affects the way that the graph looks. And so these are sort of my 3 cases here. Okay? F of x equals x squared. This is just my regular x squared graph. Whoops. My regular x squared graph. And then here, through 0.3x squared versus 4x squared. Well, compressions or stretches, hopefully you notice that compared to my base x squared graph here, this one gets wider, right? And this one looks a little narrower. And so that's basically what happened. This here a value, right, is less than 1 but greater than 0. And this a value is greater than 1. And so when that happens, right, a is the value which is multiplied. That's this 0.3 and this 4. The 0.3, if it's in this case between 0 and 1, meaning it's definitely a fraction or a decimal, it's going to make the graph wider. And if it's greater than 1 here, this 4, it makes it narrower. Okay? If the a value is just 1, it's just going to be the base function, right? It's the x squared, how we've always seen it. And so the rules are sort of written out right here. These right here are absolute value of a. And we'll remember that those make the a values positive. So we're only looking at the positive values here because we've already talked about the negative. The negative is the reflection, which flips it over the x-axis line. Okay. Finding x and y intercepts. I'm pretty sure you looked at these two concepts in Algebra 2, but just a refresher here. The y-intercept, and we've looked at this in y equals mx b, but that's the y-coordinate in a point where the graph crosses or touches the y-axis, and the x-intercept is the x-coordinate in a point where the graph crosses or touches the x-axis. So looking at my graphs down here, first of all, we'll notice we have some translations. This one's +1 minus 2. So So this went left 1 and down 2, and there's also this 2 value here, and so this graph got a little bit skinnier. And this one, there is no vertical translation. There's only this horizontal inside. So this one just went right 1. It doesn't go up or down, because technically this is like plus 0 out here. And then this negative flips it over so it faces downwards. Alright, but what we're looking for here is x and y intercepts. So in my first graph here, where does this graph cross the y-axis, right? The y-coordinate. Well, the y-axis is my line right here, right? And so my graph crosses that at this point. And so what point is that? Well, that's 0, 0. And so my y-intercept is the y-coordinate of that. And so my y-intercept is 0. Okay? My x-intercept is the x-coordinate where it crosses the x-axis. So this 0 is also where it crosses the x-axis, right? And so this right here is an x-intercept. But this is the x-axis. Excuse me. And it also crosses right here, right? The x-axis. And so this point is at negative 2, 0. And so again, I want the x-coordinate, and so I also have an x-intercept at negative 2. Okay? Same thing in this graph. I noticed that here is my x-axis, my y-axis, and so this graph crosses the y-axis right here, which is at negative 1. So my y-intercept, oops, I'm doing this in the wrong colors than over here. Alright, well, I'll flip them. Getting a little crazy. Oh man. And my x-intercepts, where it crosses the x-axis. And notice it doesn't cross, but it does touch, right? And so it touches the graph right here. And so this is at the x-intercept, which is at 1. Okay? And so basically that's the lesson. I know there's a lot in there, so we're going to talk about this tomorrow in class. Just to make sure that you watched this, I'm going to put up a CPP for today. So add this up and enter it into the CPP. Alright, see you guys tomorrow.